Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood, and today we're going to be learning all about volcanoes. But before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. When we see volcanoes in cartoons, TV shows, and movies, we often see characters dangling over a giant, open pit of bubbling lava that's just sitting there waiting to boil over. But is that how volcanoes actually work? Are the tops of volcanoes essentially an open swimming pool of magma? Or is that just a Hollywood fabrication? What do you think? We'll find out at the end of the episode. Now for your word of the day. Our word for today is caldera. That's C-A-L-D-E-R-A. A caldera is a specific geological feature that's often confused with a standard volcanic crater, but it's actually much larger and forms in a very dramatic way. While a crater is usually formed by the outward expulsion of rocks and other materials from a volcano, a caldera is created by an inward collapse. This happens when a massive volcanic eruption empties the magma chamber beneath the volcano, leaving the ground above with no support and causing it to cave in and form a massive cauldron-like depression. The word caldera comes from the Spanish language, which in turn took it from the Latin word calderia, meaning cooking pot. It's the same Latin root that gave us the English word cauldron. It's a fitting name because these depressions can be many miles wide, and in some active regions, like Yellowstone, they act like giant pots, heating the geothermal features above them. Time for your daily high five, our top 5 fun facts about volcanoes. Number 1. A volcanic eruption can create its own massive electrical storm known as a dirty thunderstorm. You might think that lightning only happens during heavy rainstorms, but volcanoes can actually generate incredible lightning displays entirely on their own. As rock, ash, and ice particles are blasted out of the volcano, they violently collide with each other in the volcanic plume. These millions of collisions knock electrons loose, creating a massive buildup of static electricity that eventually discharges as jagged bolts of lightning right in the middle of the erupting ash cloud. This phenomenon is visually spectacular, but it also helps scientists monitor eruptions that might be too dangerous to approach or obscured by darkness. By tracking the radio waves produced by these lightning bolts, researchers can tell how much ash is being spewed into the atmosphere and how intense the eruption is. It's a terrifying yet beautiful example of how much raw energy is released when our planet decides to let off a little steam. Number 2. The largest volcano in our solar system is not on Earth, it's on Mars. While Mount Everest and Mauna Kea are impressive, they're tiny compared to Olympus Mons, a shield volcano located on the red planet. It stands about 13.6 miles or 22 kilometers high, making it roughly 2.5 times the height of Mount Everest. It's so incredibly wide that if you were standing on the surface of Mars at the base of the volcano, the peak would be beyond the horizon because of the planet's curvature. Olympus Mons was able to grow to such a staggering size because Mars doesn't have mobile tectonic plates like Earth does. On Earth, the plates move over hotspots, creating a chain of smaller volcanoes like the Hawaiian Islands, but on Mars, the crust remains stationary over the lava source. This allowed the lava to pile up in the exact same spot for millions and millions of years, slowly building the largest mountain in our solar system. And if you want to learn more about Mars and the other planets, check the links in the show notes. And as long as I'm talking about space volcanoes, here's a little bonus fact for you. Not all volcanoes in our solar system spew hot lava. Some of them actually erupt ice. They're called cryovolcanoes, and they're found on distant icy moons like Saturn's Enceladus or Neptune's Triton. Instead of molten rock, these volcanoes erupt volatiles like water, ammonia, or methane that are usually frozen solid but get heated by internal pressure. When they erupt, it comes out as a slurry of icy water that instantly freezes upon hitting the cold vacuum of space, creating snow in the cosmos. Number 3. In the 19th century, there was a single volcanic eruption that was so massive and powerful, it basically canceled summer for the entire world. In 1815, Mount Tamboro in Indonesia erupted with such ferocity that it's still recorded as the most powerful volcanic eruption in human history, at least recorded human history. The explosion blasted so much ash and sulfur dioxide into the atmosphere that it formed a veil around the Earth, blocking out sunlight and lowering global temperatures. This led to the year 1816 being known as the Year Without Summer, where snow fell in New England in June and crops failed across Europe and Asia. But if we're trying to look on the brighter side, this gloomy weather did lead to some human creativity and invention due to the lack of resources. Because the horses were starving from the lack of oats due to the crop failures, a German inventor named Karl Dreis created the running machine, which was an early ancestor to the bicycle to get around without animals. Number 4. When we think of volcanoes, we typically think of them on land, but the majority of them are actually underwater. Scientists estimate that about 75 to 80% of all volcanic activity on Earth actually happens underwater. These are known as submarine volcanoes, and they're located primarily along the mid-ocean ridges where tectonic plates are pulling apart. As the plates separate, magma rises from the mantle to fill the gap, creating new ocean floor and vast underwater mountain ranges that humans rarely see. These underwater eruptions are fascinating because the extreme pressure of the ocean water suppresses the explosive gases, resulting in unique lava formations. One of the most common formations is called pillow lava, where the molten rock hits the cold water and instantly forms a hard crust that looks like a round pillow or tube of toothpaste. These deep-sea vents also host incredible ecosystems of tube worms and crabs that survive on the heat and minerals from the volcano rather than sunlight. And our fifth and final fun fact for today. Despite their destructive power, volcanoes are actually responsible for creating some of the most fertile farming soil on the planet. It might seem counterintuitive to live right next to a dangerous volcano, but millions of people throughout history have settled near them because the agricultural benefits are unmatched. When volcanic ash and rock break down over time, the process known as weathering, they release a rich supply of nutrients like potassium, phosphorus, and calcium into the ground. This creates andesols, a type of soil that's incredibly effective at holding water and feeding plant roots. This is why regions surrounding volcanoes, such as the area around Mount Vesuvius in Italy or the volcanic islands in Hawaii, are so lush and productive for farmers. These areas can produce high yields of crops like grapes, coffee, and tomatoes that might struggle in other types of soil. Just another reminder that nature often works in cycles where destruction eventually paves the way for new life and growth. Now for some news you can use. If you want to up your baking game at home, take a lesson from the pizzerias in Naples, Italy. I know the subject for today is volcanoes, but bear with me here. Many famous ovens are lined with volcanic rock from Mount Vesuvius, but you can replicate the science in your kitchen using a baking stone. Whether they're made of volcanic basalt or porous ceramic, the stones work because of thermal mass and porosity. First off, that thermal mass. The stone absorbs and holds on to the intense heat. This prevents the oven's temperature from dropping when you open the door or put in a cold dough. Second, the stone is porous, meaning it actually absorbs moisture from the dough as it bakes. By drawing water out rapidly while delivering consistent high heat, the stone allows the crust to become perfectly crisp without burning. A metal baking sheet just can't compare because the metal traps the moisture against the dough. And these baking stones are good for more than just pizza. The volcanic method is incredible for baking artisan breads like sourdoughs or baguettes, giving them that bakery-style oven spring and crunch. You can also use the stone to roast vegetables. The high conductive heat will give peppers and zucchini a delicious char that tastes like they came off the grill. And surprisingly, it can even be great for cookies because the stone distributes the heat so evenly it prevents the bottoms from burning before the centers are cooked. Just remember, when you're using these stones, you always want to put them in a cold oven and let it heat up gradually. This is because rock is very strong, but also brittle and susceptible to something called thermal shock. If you expose a cold stone to sudden intense heat, the outside of the stone will expand much faster than the cool inside, creating internal stress that will snap the stone right in half. Now for the moment you've been waiting for. At the beginning of the episode, I asked, are volcanoes basically just a giant open swimming pool full of lava? This one's a fallacy, at least for the most part. The cartoon image of a bubbling lava lake at the top of the mountain is extremely rare in the real world. In fact, there are only a handful of persistent lava lakes on Earth, like the one at Mount Erebus in Antarctica or Erd Ale in Ethiopia. For the vast majority of volcanoes, the magma is stored deep underground in a chamber, and the top crater is either solid rock filled with water or covered in ice and snow. So, if you hike to the top of most volcanoes, you won't see bubbling red liquid. You'll just see a rocky, quiet depression. Now, I hope you enjoyed learning a bit about volcanoes with me today. Be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.